Aircraft, the most common transportation tool which enables human beings to travel in long distance nowadays, for example from countries to countries. The existence of aircraft not only makes our lives more convenient, it also enhances the development of the whole human civilization. Every day, thousands and millions of aircraft take off and land on airports, carrying different people and stocks. We believe that you must have the experience of traveling by an aircraft, but do you really know how and why it works? In our videos, we are going to introduce about the basics of an aircraft. But for such a complicated design of an aircraft, it's impossible to explain all the components on it. So we will just pick up one part and try to explain it in a deeper sense. The part we are going to talk about is the tail part of an aircraft. The tail part is one of the most important parts for an aircraft, and in the series of our videos, we'll briefly talk and discuss about different types of tails, the manufacture process of tail parts on a written RC plane, and lastly, there will be an interview on the former joiner of the AIAA DBF competitions. Through these videos, hope that you can gain a basic knowledge on the aircraft tail part, and hopefully it could help you on building your own tail parts in the coming AIAA competition. Just as a reminder, the videos made are just for reference and might not be 100% correct. In better sense, one should read and study for extra information from the internet or textbooks. So, to start with, in this video, we will introduce you what a tail part is and what are the basic functions for it. So, what exactly a tail part is? Literally, just like what its name is, a tail means the aft part of an aircraft. Just as an example, this is the tail part of an aircraft. But in fact, instead of the whole aft part, what the tail means is focused on the lifting surfaces on the aft part. They can be basically divided into two components, the one attached horizontally, the horizontal stabilizer, and the one which is attached vertically, the vertical stabilizer, or we call it the fin. Instead of just a simple plate attached on the fuselage, generally there will be control surfaces on these stabilizers. The control surface on a horizontal stabilizer is called the elevators, where the one on the vertical stabilizers is called the rudder. Control surfaces are generally movable and they can be controlled by the pilots through the pedal or yoke inputs on real aircrafts. One interesting thing about tail is that the tail may not be attached on the aft part of an aircraft, depending on its function. For example, a Carnot configuration is a tail configuration that the horizontal stabilizer attaching in front of the main wing. Hence, it is more accurate to call the tail part the empennage instead of the tail. But for convenience, in the following parts and videos, we will still use the word tail as it is the majority configuration among the aircrafts. In fact, there are many different kinds of tail configurations and many of them are very interesting. And this would be discussed later in the next video talking about the configurations of tails. So, what is the main functions of a tail and how does it work? One thing which is important before you know how the tail part functions is the body axis system of an aircraft. To indicate the aircraft motions, first, the body axis system has to be defined. Just like normal coordinate systems, there are three x-axes in the body axis systems, which is x, y, and z. Assume an aircraft with its CG, the center of gravity, located as drawn by the red mark. The x-axis of an aircraft in the body axis system is an axis pointing from the CG to the cockpit, or the head of an aircraft. The y-axis is the axis point out from the CG to the outside, following the right wing. Then by right hand rule, turning from x-axis to y-axis. The z-axis is the axis pointed out from the CG and perpendicular to both the x and y axes. And again, by the right-hand rule, the free rotational motion of an aircraft could be defined, and the red arrows indicate the positive rotations of each axis. Pointing the thumb in the same direction as the x-axis, positive rho is defined as if the aircraft rotates in clockwise direction along the x-axis. And similarly, on the y-axis, the rotation along this axis is defined as pitch. And lastly, for the z-axis, the rotation along this axis is yaw. So, how is this related to the functions of tail? There are two main functions of tail part. First, to maintain the aircraft stability, and second, to provide control in aircraft maneuvers. Let's talk about the first function first. Maintaining stability actually equals to one single word: trim. Trimming the aircraft means the aircraft is not rotating. In other words, all the moments in the free axis are balanced. It is very important to trim the aircraft in order to avoid stall and maintain a steady flight. Let's assume an example to see how the tail helps balance the aircraft in terms of pitching moment. Assume there is an aircraft without a tail part, and it is in straight and level steady flight, flying towards left. Again, the CG is assumed in a position behind the wing. In such situation, the force distribution is simply like a weight pointing downwards from the CG, which is dominated by W, and a lift force by the wing pointing out from the wing aerodynamic center, which is dominated by the LWF, where WF stands for wing and fuselage. Also, there will be a twist or a turning moment by the wing, as the lift from the wing is actually not from a single point, but they are unevenly distributed over the wing surface, and it is dominated by the MAC. Take the moment at the CG. The weight could be ignored as it is from the CG. Hence, there will be a net pitch-up moment by the lift L from the main wing together with the MAC. In such case, the aircraft will tend to pitch up and up to a certain angle of attack, which is typically larger than 15 degrees, the aircraft may stall and lose control. But if there is a tail part at the aft of the aircraft, a lift force LH will extend for horizontal stabilizer will be produced, and hence an opposite pitching moment will be produced. Also, there will be still a moment due to the uneven lift distribution on the tail wing surface exist, but as the wing surface of the tail wing is too small, the twist could be ignored. With suitable moment produced by adjusting the position of the tail and the CG, and also the amount of lift by the tail, the net pitching moment could be balanced. And this is how the tail parts help trim the aircraft in terms of the pitching moment. For rolling and yawing moment, as the aircraft is symmetrical in the XZ plane, periodically they don't need an extra thing for them to trim. Controlling the aircraft motion is the second function of the tail parts. As mentioned, on the tail wings, there are control surfaces. On the horizontal stabilizers, there are elevators, where on the vertical stabilizers, there are rudders. When the control surfaces are moved or adjusted, it can change the aircraft's motion through applying moments. Take the horizontal stabilizer as an example. This is the side view of how a horizontal stabilizer looks like, with the elevator attached at the back. The elevator could be controlled and could be turned up and down depending on the pilot's input. Generally, tailparts have symmetrical airfoils, so assume that it is also a symmetrical airfoil for the tail in this example. When the elevator turns down, airflow fluid will be guided and pushed downwards. According to the Newton's law of action and reaction force, it will cause an upwards force on the horizontal stabilizer, and that's the lift it produced. But if the elevator is not turned and the horizontal tail is symmetrical, no flow will be deflected downwards and hence no lift would be produced. So this is how generally aircraft are trimmed, which is a suitable angle of elevator is applied. But sometimes, a trimmed condition may not be wanted, like if the aircraft needs to descend, the elevator has to be further deflected down so that the aircraft could start to pitch down. And after a desired descending angle is reached, the elevator will be adjusted again to go back to the trim stage to get a steady descending of the aircraft. By a similar manner, the yawing motion could be adjusted through the adjust of rudder angle. To get a positive yaw, which means yawing the aircraft to right, it could be done by applying a right rudder. But actually, yawing is not frequently used in air, and in fact, the use of rudder is always on ground, like during taxiing, and there is some slight slip of wind. This is why the tail part is essential to the aircraft and how they works. In fact, apart from these two functions mentioned, different kinds of tail have different properties, and as they play such an important role in flight, the choice and design of tail part must be accurate and suitable. So, in the next episode, we will discuss about different configurations of tail and compare among them. That's all for this video, and thanks for watching. See you again in the next video. Bye.